extra risk might be. The writer would consider things like the amount of time left till expiration, the volatility of the stock. Now, let's assume that the writer estimates that this additional risk is 3 points. Again, here we're just estimating that for our example. So the writer should therefore demand a total premium of 7 points, or $700. Now, this would consist of 4 points of intrinsic value and 3 points of time value for the two types of risk. So the premium for an option would always consist of those two parts, intrinsic value plus time value. Now, a variation of this formula that is often more useful is premium minus the intrinsic value equals the time value. Now, the intrinsic value can be determined mechanically. That is, all we have to do is to look at the option, look at the situation, and figure out if this option is in the money. If it is in the money, the amount is the intrinsic value. That's all there is to it. But the time value is a little bit more complicated to deal with. The market, in fact, would tell us what the time value of the option should be. You may have to, in fact, figure out those two components of an option premium. How much is intrinsic value? How much is time value? So let's look at some examples of these types of problems. In this example, the investor buys a February 60 call at a 5-point premium. The market value at that time is 61. And notice that they give us the premium directly in the problem. It's given as 5 points. Now, next, we want to find the intrinsic value of the option. Now, this is the amount that the option is in the money. We note that this is a call option. Now, remember how to figure out whether a call is in the money? You think call up. The stock price is 61, which is above the strike price of 60. So this call is in the money by 1 point, which is its intrinsic value. And finally, the time value is determined by taking the premium and subtracting the intrinsic value. 5 minus 1 gives us a time value of 4 points in this particular situation. So the procedure that we use when we're breaking down a premium into these parts is first, find the intrinsic value, which you can do if you know the type of option, the market value, and the strike price. And then once you know the intrinsic value, subtract that from the total premium, and whatever is left over must be the time value. Now, since these concepts are used frequently, let's do one more example in this case. In this situation, we're selling an ABC August 90 call at 6. The market value is 88. Now, first of all, we have to find the amount that the option is in the money. That would be the intrinsic value. Again, since it is a call option, think call up. Is the stock price above the strike price? Well, not in this case, since the stock is only at 88 and the strike price is 90. Since the option is out of the money, what is the intrinsic value? Well, the intrinsic value is 0. And once we have determined the intrinsic value, we subtract it from the premium to find the time value. So 6 minus 0 would give us a time value of 6. Now we've been looking at the premium. Of course, this is the amount that the buyer of the call pays to the writer of the call to offset the risk that the writer is taking that they might suffer a loss on the exercise of a call if that occurs later on. Again, this is what the writer and the buyer estimate is a reasonable compensation for that risk. But remember that we do that at one point in time, whereas the exercise of that option might happen sometime later. And who knows what the market values of the stock would be at that particular time. So the question is, if we know what the premium is up front, the compensation for risk, did that actually turn out to be enough compensation for the writer? It turns out in some cases it will be, but in some cases it won't. So let's pick up the story of the investor who has sold the XYZ January 50 call at 7. Now remember what that means. The writer has an obligation to sell the stock at 50 if assigned, and by accepting this 7-point premium, remember that is supposed to be the compensation to the writer for potential risk, the seller is saying that the stock will probably not rise more than 7 points above the strike price. So we've got the strike price here right now. We get 7-point premium. We don't think that the stock will go much beyond that $50 strike price. So the premium will shield the investor from up to $700 worth of losses. For example, suppose that as of the expiration date, the market value of the stock is at 55. The writer would probably receive an assignment. This would require the writer to purchase the stock in the open market at 55 and then sell it to the owner of the call for 50. The result is a $500 loss for the investor. Or is it? Now remember that the writer received a $700 premium up front and therefore actually makes $200 overall. So the $700 premium that they received offset the later loss of $500 and then some. But suppose the stock goes to 62 instead. Then upon exercise, the writer will have to go buy the stock at 62, a much higher price, turn around and sell it at 50, and then lose this entire difference of 12 points per share or $1,200. And notice if that occurs, this 7 points that we received up front for the premium no longer covers our loss later on. We actually do have an overall loss. Now from this, we can see that if the stock price is more than 7 points above 50, any place above this zone that we've marked up here, the writer will have an overall loss. The opposite of that transaction is that the owner will profit. On the other hand, if the stock falls below this critical level, then the owner will lose and the writer will profit because the writer will make more money on the premium up front than they lost on the eventual exercise of the option. So again, if the stock does not go up by more than 7 points, then the writer is in a good position. So it's important to note that the critical value in this situation is not necessarily the strike price of 50. The critical question is, how big was the premium? And then, what is that premium in relation to the strike price of the option? So it's possible in that situation for the investor to make money even though the option contract would be exercised. Now that critical point that we'll be looking at, those 7 points beyond 50, we call that the break-even point. So notice for call options, the break-even point is the exercise price plus the premium. And again, another thing that we can do to remember is to think call up. If I take the strike price and add, I go up by the amount of the premium. Now, we've discovered many of the properties of call options. We begin to create a diagram that is designed to help you remember many of the basic properties that call options have. And one of the things you should be able to do is to construct this diagram from memory so that when you go into the Series 7 exam, you are able to write down these critical clues. Now, when you put this diagram together, let's just see how the basic diagram is constructed. It's going to be divided into 4 quadrants. So you've got one line across the middle and one vertical line here. So you've got 4 different points. And notice conveniently that that corresponds to the fact that options investors could find themselves in 4 basic situations. You could be the buyer of the call or the seller of the call, or the buyer of the put or the seller of the put. So those are the 4 basic cases. Now, how do you remember where to put these entries? We'll go back to our basic ideas, but remember it's going to be call up. So calls are going to be above the line and puts are going to be below the line. So on the left you have buyers and on the right we have the sellers. So that's why this quadrant would correspond to a person who buys a call, the long call. This quadrant corresponds